Hey everybody! Today we are looking at how to use Blender to create a stop motion effect, similar to the style of some of the old traditional Christmas movies, like Rudolph and Santa Claus is Coming to Town. In order to start, you will need a copy of an existing animation to add the effect to. I'll be using this clip of Little Llama doing a slow walk, but you can use anything. As with most things in Blender, there are a multitude of ways to do this, and we'll look at a couple. We'll also see how Python can help us out by automating some repetitive tasks. If you have any of your own tips or methods, be sure to share them in the comments. I'd love to know your thoughts. We're going to look at using fewer frames through render settings to add some abruptness to your animation, adding some movement to some of the frames to create some of the natural stop motion imperfections, and finally how to use all of your existing frames if you don't want to alter the speed of your animation. We'll use a couple of Python scripts along the way, which I'll explain thoroughly. I'll also provide my scripts in GitHub if you want to modify them for your own use. I have to provide the disclaimer, however, that you are responsible for the scripts you run against your own animations, and I make no claims to my scripts' veracity. They may not be suitable for all animations, so please be sure to run them on a copy of your animation so you don't alter any work you aren't okay with losing. One of the first and most obvious things we can do is to tell Blender just to use every third frame, which we can set in the Output tab of the Properties window. This will, however, speed up the animation quite a bit, by 3 in this case. But since my walking animation is slow anyway, this might be alright. I'll go ahead and render that without any other work taking place. This produces a much faster walk, but it is lacking in the subtle variance of movement that is one of the hallmarks of stop motion. You can do this manually if you like, picking a few bones to rotate slightly throughout the clip. I'm not that patient though, and the longer the clip, the longer this takes. So I'm going to use a Python script to produce some random rotations. This is that script, addVariableMovement.py. The first thing to do is import modules, specifically BPY, which lets us interact with Blender objects, and the random and math modules, which are used for creating random values for the rotations and expressing that value in radians. Next is a function to create either a positive or -1 multiplier, so the direction of the movement is variable as well. Next are the variable instantiations, where the values are set that are going to be used further down. So if you need to adjust the values when running on your own animation, this is the place to do that. There are variables for the start and end frame, the step increment, and the low and high range for our rotation. I started by using a range from -1 to +1, but I found that a lot of the values produced were close enough to 0 to be indistinguishable from the prior movement. We are going to randomize our bone selection, and we are going to limit that to just a few bones here. Your bone names will likely vary, and this is the place to put those. Next, the current object is set to a variable so that it can be worked with throughout the script. Next is a check to be sure that the current object is an armature, and to be sure that pose mode is the current mode. If we are not in pose, this line will set it to pose mode. Then the loop over the frames starts here, specifying the start, end, and increment of the loop. Next, we set the frame in our scene to the frame number. Then we are going to set the bones variable equal to a collection of our pose bones. This is a check to be sure that the bones we have provided in our list exist in the armature. We are going to use some modulo logic here, which is essentially the remainder of integer division. This is going to ensure that when we integer divide the frame number by the step interval multiplied by 3, that we have a 0 remainder. If that's not the case, we are going to use the previous loop's rotation amounts and apply those to our animation. So we will have 3 increments of a similar rotation. I did try randomly moving bones for every keyframe, and this gave us a very frantic pace for our animation. If that's the look you're going for, then you can remove the if statement and unindent the 6 lines below it by one tap. When we are at the point where we want to change our rotation, we start by ensuring that all bones are deselected, then choosing a random bone from our collection and setting the selection of that bone to true. Next, we will select random values within our range, multiply them by our random negative or positive 1, and convert them to radians. After that, we set the rotation values for the X, Y, and Z axes. And then we insert a keyframe. The setting of the rotation and inserting of a keyframe will occur each time through the loop. The rotation we are doing here is basically an offset, so that even though there is movement throughout our frames, that movement will be offset by the same amount for 3 keyframes until a new random bone and rotation is chosen. So I'll go ahead and run this to add randomness. This script will take a couple of minutes to complete. Next, I'll render once more and then take a look at what we have now. So this looks better, but it also seems a bit fast for stop motion. Plus, you might not want to speed up your animation. Not a problem, and we'll use another script for this, but I'll let you know how to do this manually if you want. Let's set our render step back to 1, and I'm actually going to go ahead and reload my original animation. The basic gist of what needs to happen is to walk through the animation and set a keyframe every 3rd frame. Then go back through the animation and delete all of the other keyframes. For this armature anyway. Once we have the animation happening in keyframes every 3rd frame, the interpolation mode needs to be set to constant. This is a lot of work to do manually, depending on how many frames there are. So let's bring up the script. This is another pretty simple script. For this one, only the BPY module is needed. There are the standard variables from the other script for start and end frame and the step. Again, the object is the currently selected object, which should be all of the bones in the armature. This top if statement just ensures that we have an object selected. This script would also work for other animations without an armature, but the variable movement script would require modification. The first loop will use the step increment, so in this case 3, but you can adjust this by changing the value for the variable up top. And in this loop, the current frame is set to the increment frame, and then a keyframe is created there. The second loop is going to touch every frame from the start to end values, incrementing by the default 1. This if statement uses the modulo operator again, or the integer division remainder. So if there is a non-zero remainder, then it will run the remainder of the statements. And these statements essentially find all of the F curves and remove them. I'll run the keyframing step first, and then the variable movement script. If you run them in reverse order, it can cause some unexpected glitching in your animation. And now that the keyframes are straight, we can select all of the bones, select all of the keyframes, and then set the interpolation mode to constant. Additionally, to enhance our effect, let's run the keyframing script on our camera and set that interpolation mode to constant as well. I'll render this once more now. Now let's take a look at all of our renders side by side for comparison. That will wrap up this tutorial. I hope you've enjoyed this video and found it useful. If you have any questions, comments, or feedback, be sure to leave it below. Don't forget to like and subscribe for more Blender content, and check out my other tutorials on this channel. I'll be bringing you some geometry node deep dives soon, where I'll go over a few specific nodes at a time, and discuss and demonstrate the possible ways to use them and alter their behavior. I look forward to seeing you soon, and I wish you a very happy blendering.